In a previous video, we took the major scale and we used the metric model here to sort of observe the tonal geometry of it and kind of understand how harmonies are derived from the notes in the major scale. What we're going to do today is we're going to look at some alternative scales and provide kind of a geometric argument for why these scales are important. Scales are essentially a collection of pitches that connect two notes that are an octave apart. So, for example, if I have these two notes here, I could connect them with the major scale, which I've already played 100 times, but whatever. But I could also connect them with some ridiculous collection of notes like this. And I could call that a scale as well. There's really no hard criteria for what defines a scale. Western music is often constructed by taking notes out of a scale and using them to build musical structures. One thing that was kind of cool that we saw in the last video was how if you take the major scale and you play every other note in the major scale, you can naturally create these tertian harmonies. So one thing that we can consider with this that's interesting is perhaps one of the reasons why the major scale is so popular for creating songs is because these tertian structures are really useful. And perhaps what would be a means of finding new scales would be to try to find other patterns of notes that have the same pattern, like every other note naturally creates tertian structures. So to summarize, we're going to be creating scales, and our criteria for creating these scales is they must connect two notes exactly an octave apart, and every other note of the scale must make a tertian harmony. I want to add one more criteria to our search, and that's that when we're looking for different scales, I don't want to be discovering different modes of scales. And a mode is essentially the same thing as a scale, except for you're starting on a different pitch and emphasizing a different pitch than what's usually expected. So, for example, if I play for the 101st time the major scale again, but instead of starting on this note, I start on this note instead, I get what might sound like a different scale. But the problem with treating this as a completely different scale is, even though it sounds a little bit different, if you're trying to build music from it and you're trying to construct structures from it, since all the interval sizes are exactly the same, I mean, the only difference is we just started on a different note, you end up getting the exact same structures from it. So a little bit of time ago, I was trying to come up with more scales to play on my guitar when soloing, and I used this criteria to try to figure out how many scales I could come up with that fit this pattern. I noticed that scales I knew that did fit this pattern tended to sound really good, so I figured maybe other ones I could discover with it would also sound good. And the way I went about doing this is I took out graph paper and I would separate out sections of 12 on it, for a scale, and basically fill in a couple notes that were a certain distance apart in semitones, and then kind of fill in the blanks by putting notes in between them, and try to make sure to maintain that pattern of every other note is always 3 or 4 semitones apart. And anytime that I realized I'd messed up the interval pattern, or that I had created a mode of another scale, I would cross it out. And after a fair amount of time using this criteria and using this method, I came to the conclusion that there's about 7 total scales that fit this pattern. And what's kind of interesting is some of these scales are very well known and get a lot of attention, but others of these scales don't quite get mentioned as often as they probably should be. So one of those scales, of course, is, the scale we always talk about, which is the pitches do, re, mi, fa, sol, la, ti, do. And I usually like to think of it as re to re for reasons I explained in the last video, but either way, this is, of course, the most obvious of these 7 scales. But one thing that's really, really interesting about this is we can actually account for 3 of the other scales just by adjusting our pitches, do, re, mi, fa, sol, la, ti, do, very slightly. And some really interesting, cool patterns show up when we take our scale and we make those adjustments and then we view it on our model. We can achieve these three scales very easily. We can create them by taking our normal set of solfege pitches and just shifting one pitch. The one pitch, though, that we're never going to shift on its own to create one of these scales is re. And the reason we'll never shift re is because if we shifted on its own upward, we'd get re, mi, fa. And then every other note, meaning re, fa, is now only two semitones apart, making it too small to create a tertian structure. And similarly, if we shift it downward and we get ti, do, re, T, re is also only two semitones apart and would also be too small to create a tertian structure. The first scale that I want to mention that we can create by adjusting our solfege pitches is a scale that almost every musician's heard of, referred to as the harmonic minor scale. And we can simply create the harmonic minor scale by taking a pitch that we would normally refer to as so and raising it one semitone to a pitch that we could rather instead just call C. And what's great about this is, while we still have this pattern of every other note will create a tertian structure, by shifting this one interval, we've dramatically changed where in the scale those tertian structures occur, and it completely changes the sounds that come from it. The next scale that I want to mention is a scale that I didn't even know existed until I did this experiment. And after finding it, I looked it up online and realized some people have been calling it the harmonic major scale. And the harmonic major scale is a scale that gets left out, usually, of traditional music theory education, despite the fact that it actually provides a really good explanation for some of the choices that composers have made in the past. What's interesting about the harmonic major scale is you create it in a pretty similar fashion to how you create the harmonic minor scale. Just rather than raising so to C, you instead lower la to a pitch we could call lay, and end up covering the same tone that you would cover by, well, raising so to C. What's also really, really cool about the harmonic major scale is it kind of provides a mirror image to the harmonic minor scale. A lot of the patterns that exist in the harmonic minor scale also exist in the harmonic major scale. They just sort of come in a mirror version of it. The third scale that we're going to look at is a scale that's been commonly called the melodic minor scale. And we could achieve this one of two ways. We could either just shift do upwards to a syllable we could call D to create it, or we could shift mi down to a syllable we could call me to also create this scale. Personally, in my own schooling, I was taught a different arrangement of solfege syllables to create this, but I really like this way because, well, it fits our pattern. And because we have this nice pattern with all these, just shifting one solfege syllable to represent these different types of scales, it can ultimately cut down on a ton of memorization that normally musicians are reliant on for learning scales. You might have noticed that there's two syllables we haven't shifted, and those would of course be shifting T down to a syllable we could call te, or shifting fa up to a syllable we could call fi. And while shifting these two syllables isn't going to actually create a new scale, what is kind of cool about it is shifting fa up to fi or shifting T down to te is kind of like the equivalent of shifting your key signature up a fifth or down a fifth. And those two shifts happen to be the most common key changes in Western music. So there's still kind of an interesting pattern to be found, even with the two syllables that we wouldn't normally shift. And to make it even, well, I guess more interesting, if you shift both T and Fa simultaneously, you actually create a mode of the melodic minor scale. So if I include our original set of pitches, we've actually been over 4 scales so far. So that would be the major scale, the harmonic minor scale, the melodic minor scale, and the harmonic major scale. I put these names in quotations because, well, they get called a lot of different things depending on which mode of any one of these scales you play. So there's actually 3 scales left, and these scales are a little bit different. what makes these scales interesting is each one of the scales we looked at before is going to create a variety of types of harmonies. It's going to create some major, some minor, some diminished, and even sometimes some augmented harmonies. But these scales, each of them is only going to create one type of harmony, and it's because these scales are so symmetrical. So the first one is the whole tone scale. And it's basically the same as playing a note, skipping, and then playing another note, and then skipping a semitone, and then playing another note. And this fits all of our criteria, and if you take every note and you play every other note from it, well, you always get an augmented structure every single time. And very similarly, we have a scale that I've seen referred to as the altered scale. I'm not really sure what to call it. That's what I've seen it called. And it's kind of similar where you have a note, and then the next note will be one semitone above. And then there's a 2 semitone gap, and then you play another note, and then the next note is a semitone above, and then there's a 2 semitone gap again. And this pattern repeats. It also fits our criteria. And once again, every other note always creates an augmented chord. And finally, we have a scale that's called the diminished scale. And it follows a pattern of note, note, and then there's a semitone where no note is played. And then note, note, and then no note, and then note, note, no note. It sounds a bit like a tongue twister. And the diminished scale also, every other note creates a structure. Just this time, every one of those structures is, I guess appropriately, a diminished chord. These are the 7 scales that naturally create the tertian structures that are fundamental for creating Western music. Normally when we learn about these scales, we learn about them through hearing them or through studying how composers might have used them in the past. But what's really nice about looking at them and analyzing them from a geometrical perspective is it can give us a whole other avenue of understanding how they're important and how they contextually relate to one another. I'm not sure at this time what my topic's going to be for the next video and how I'm going to follow this up, but hopefully it'll be soon. Thank you for watching.